Hello, this is going to be a little run through on how to factor a trinomial into two binomials. Now I'm working on an iPad with just my finger, so bear with me if it's not the neatest in the world, but I think we can get the job done. Now what I've got here is a trinomial, 6x squared plus 19x plus 10. The first thing you should always do is just double check real quick before you try to factor this into two binomials. Double check that you do not have a GCF, a greatest common factor, that can be factored out. At this point, 6, 19, and 10 do not have a common factor other than 1. And when we look at the variables, well, I don't have an x in the last term, so I also can't factor out an x from each term. So I'm ready to move on to trying to break this trinomial down into two binomials that would multiply together to equal that trinomial. Now, binomials have two terms. Bi means two. So what I'm actually looking at is filling two parentheses that when multiplied together, this will be times, and you may have heard of FOIL, when FOILed together, will create a 6x squared plus 19x plus 10. Here's how I show the process. First, I list out all the pairs of factors of the first term, the 6x squared. Now the x squared, I'm always going to factor that into x times x. So then I have to worry about the 6. Well, factors of 6 would be 1 in itself, so I can have a 1x and a 6x, or 2 times 3. So a 2x and a 3x. Now I like to put a little line in between each pair of factors. I'm also going to do the same thing for the last term. I do not do this for the middle term. Note that my terms are in descending order of degree. I have the x squared term first, the x to the first term second, and the constant, which is really a degree 0 term, last, the 10. Now factors of 10. Obviously 1 in itself, 1 times 10. Another pair of factors that will multiply together be 10 is 2 and 5. 2 times 5 is 10. And that's it. Make sure you list all the pairs of factors of each number. If you accidentally forget a pair of factors, it very well could be that the pair you forgot is the pair that's needed to get your trinomial factored. And then you'll be thinking that it's not possible, when in reality, it was possible, you just didn't look at each pair of factors. So, double check that you've got all the pairs of factors of 10, all the pairs of factors of 6x squared. And in this case, we're good. Okay, here's what comes next. We are looking for products that are made from multiplying. Okay, just to show you real quick as an example. Multiplying the two factors in one pair by two of the factors in another pair. We're trying to get products. We're multiplying. So I would do 6 times 10 as I drew those lines. 6x times 10 would be a 60x, and 1x times 1 is a 1x. We're trying to get products over here that will add up to equal 19. Now that is not 19, but that's the goal, is to find a pair of factors from the red list and a pair of factors from the blue list that can create products that will add to equal 19. Now I didn't find it. Does that mean that the 1 and 6, the 1x and 6x, and the 1 and 10 are not the right pair? Well, not necessarily. If I crisscross and change how I multiply, I potentially can get a different result. And I want to make sure I test all possibilities and go through in some systematic way so that I don't accidentally skip over the combination that's going to work. Now, after you've done enough of these, you'll get much better at anticipating where you're probably going to find the factors that work. But in the beginning, or if you just ever get stuck on one and you can't do it, go back in a nice systematic order and make sure you've double-checked every single combination. Now, as you can see, I've crisscrossed it this time, and I get different products. 6x times 1 is 6x, and 1x times 10 is 10x. And if I add 6x and 10x, I get, not 19x, but closer, 16x. So It didn't work, but you can see I got quite a different result from before, and you do want to double check all the different combinations. Now at that point, I know that it's not going to be the 1x and 6x paired with the 1 and 10. That still doesn't mean that the 1x and 6x are ruled out. Excuse me. Next, what I could do is either find it or potentially eliminate the choice of the 1x and 6x if I go ahead and try it with the other pair of factors, the 2 and 5. Now right there I'm seeing a 30 and a 2. Well, 30 plus 2 makes 32, not 19. I can look at what I would get if I crisscross. 6 times 2 is 12. This looks like it might be more in the ballpark of what I want. 5 times 1 is 5. Well, close, but not what I need. That's going to make 17. Okay, so I've just tried the 1x and 6x with both the 1 and 10 and the other pair, the 2 and 5. And I tried not only straight across, but I tried crisscrossing, and I did not get a 19. So I have tried the 1x and the 6x with everything. At that point, I can rule it out. I know that it's not going to be the 1x and 6x. So, now, if it's going to be a trinomial that's factorable, it's going to have to come from the 2x and 3x. So, let's try here. And remember, I'm looking for products that will make 19. I think I see it. I'm looking straight across right here. I'm seeing 3x times 5, which is 15x. And then I see a 2x times 2, which is a 4x. And 4x plus 15x is 19x. I did it. Okay. Well, almost. The next step, now that I've found products using one pair of factors from this list and one pair of factors from the other list, the next step is getting those 4 factors into my binomials. Now, these binomials are going to have 2 terms. Don't forget, terms are separated by plus or minus signs, right? There's going to have to be a plus or minus sign in between the terms. Those signs are actually determined by the pair of factors in that second list. Okay, I was using simply a positive 2 and a positive 5, so my signs are going to be plus signs. Now, the red pair of factors, as you can see in the binomials, I've underlined the first spot in each parenthesis in red. The first pair of factors will be split up between the 2 parentheses, and they will occupy the first place of each binomial. So I will put the 2x in one and the 3x in the other. It does not matter which binomial got the 2x and which one got the 3x. However, in the next step, it does matter where to put the 2 and the 5. I can't just quickly put the 2 and the 5 in. Excuse me. In fact, many students that do quickly, before they've really learned this, make a common mistake. So watch carefully. Let's think about what I've got up above. I have these products, these lines, that made my 4x and 15x, which I know add up to be 19x, right? So look right here. I had 2 times 2, which was 4, and 3 times 5, which is 15. Now these 2 lines, I emphasize when I teach this to my students in class, that I want to see them clearly show what factor was getting multiplied to which factor. And that's because those 2 lines correspond down here to actually the O and the I in FOIL. Okay, if you think about foiling, when we're going to distribute the 2x to the other parenthesis, it'll multiply the first term, the 3x. Well, 2x times 3x is the 6x squared. Then that 2x would get multiplied by the second term in the second parenthesis. So 2x is only going to get multiplied by 2 terms. I want it, from up above I can see, that I want it to multiply with the 2. So the only other place for me to fill it in so that the 2x will get a chance to multiply the 2 is to put it in the second position of that parenthesis. And that is actually, okay, the O in FOIL. These are the outer two terms. Now, the other pair of factors, 3x and 5, those are actually the I in FOIL. If you think about if the 5 is here, when you FOIL, you would distribute the 5 to the first term here and the second term. Okay, well, you can see 5 times 2 is going to create the 10 up above. And right here, 5 times 3 is going to make the 15. So, in the end, here's what I tell my students. And I'm going to tell you, once you find these lines, once you find the pairs that go together, we are going to refer to those as our two smiles. They're really the O and the I in FOIL, but we're going to look at a little smile and a big smile. Okay? So I hope you kind of understand why the 2, this positive 2, has to be in the second parenthesis so that it multiplies the 2x. Right? Think, we don't ever distribute the 2x to another term in its same binomial. So if we want the 2x and the 2 to multiply, that plus 2 has to be in the other parenthesis. Okay, so once you put the 2x and the 3x into the binomials, then we consider the smiles. Okay, so let's go back a step. Let's pretend that I'm back to here. Once I've got the 2x and 3x, then I consider smiles. And those smiles are my lines up above. Okay, and so if the 2x is on the big smile, I have to put the positive 2 on the other end of the big smile. They have to be connected. And then the 3x and the 5, well, they have to be connected as well, and they're the little smile. Because the 3x was on the little smile, so is the plus 5. These are your two smiles. Alright, you've just factored a trinomial. Trust me, you will get much faster at this, get much better with practice. You can confirm that you did it right simply by multiplying these two binomials back together. I think we've just done that enough, but quickly you can see I would get a 6x squared, then a 4x. After distributing the 2x, then you distribute the 5. 5 times 3x is 15x, and 5 times 2 is 10. And you can see that after I've multiplied and gotten my 4 products, 2 of them are like terms that would combine to be my 19. Those should look pretty familiar numbers because I had already figured them out up here. I was anticipating that I needed to get products from foiling that would add up to make the 19. So we've done it. So we've confirmed that I did it right, and your answer is simply those two binomials. Now factoring becomes a powerful tool for you. Make sure you get good at factoring, you get lots of practice, and you'll be set to move on with your algebra class.